All right, before continuing on with transformation stuff, let's look at an example here. Let's find the domain of the function f of x equals log of 5 minus 2x. Now recall that the input of a logarithm has to be greater than 0. This means that 5 minus 2x has to be greater than 0. Here I can solve for x. Maybe it's best to subtract 5 from both sides to give me negative 2x is greater than negative 5. And then divide both sides by negative 2. And we get x is, notice that I divided both sides by a negative number. Because I divided both sides by a negative number, I have to change the direction of my inequality. So instead of x is greater than, this is now x is less than, negative 5 divided by negative 2 is the same thing as positive 5 divided by positive 2. So this is x is less than 5 halves. And this is a perfectly acceptable answer. Or in interval notation, we could say negative infinity to 5 halves, parentheses on both ends here. Let's look at transformations of logarithms. So because of our logarithm properties, transformations of logarithms are sometimes a little bit different, well, in some ways, from transformations of other functions. So our change of base property tells us that log base b of x is equal to log base b of, or log, let me start that sentence over. The change of base property tells us that log base b of x is equal to log base c of x divided by log base c of b. We could also rewrite this as 1 divided by log base c of b times log base c of x. So notice that log base c of b, this denominator here, or maybe even we can say this entire 1 over that, right? This is just a number. So this is just a number times a logarithmic function. This tells us that a vertical stretch or compression, which is exactly what this is on the right-hand side, right? We're multiplying a logarithm by some number, meaning we're vertically stretching or compressing it. This is the same as a change of base, which is what we had on the left-hand side here, whenever we're dealing with logarithms. Similarly, if we consider some function f of x equals log of c times x, using our sum property, this becomes log of c plus log of x. This tells us that because this log of c is just a number, it's a constant, that the effect of a horizontal compression, right, the effect of multiplying by something on the inside of this logarithm, is the same thing as a vertical shift. Because multiplying on the inside has become adding on the outside. I think we have a nice little table here. Not a table, but definition stuff. Any transformed logarithmic function can be written in the form f of x equals a times log of x minus b plus k, or f of x equals a times log of negative x minus b plus k if it's horizontally reflected. Notice that if the logarithm is horizontally reflected, I need to factor a minus sign out of everything on the inside. This will make these transformations more readily apparent. If I don't factor out this negative sign from a horizontally reflected logarithm, then I'm much more likely to misidentify my transformations. And here, x equals b is also the vertical asymptote. And let's look at an example. Let's find an equation for the logarithmic function that is graphed here. From this graph, it's pretty reasonable to say that I have a vertical asymptote at x equals -2, and let's see, normally logarithms go like this in terms of their graphs. So this has also been vertically reflected. So this means that so far, I know that the form of this equation looks like f of x equals -a times log of x plus 2 plus k. And I believe I have some points on this graph. I have the points, let's see, -1, 1, and the point 2, -1. So I have the points -1, 1, and 2, -1. Let's plug in the first point. Let's plug in -1, 1. F of -1 is 1. This is equal to -a times log of -1 plus 2 plus k. This gives me 1 equals -a times log of 1 plus k. Log of 1 is 0, so this is 1 equals -a times 0 plus k. And when I simplify, I get k equals 1. And now, substituting in the other point here, f of 2 is -1. This is equal to -a log of 2 plus 2 plus k, which is 1. Subtracting 1 from both sides, I get -2 equals -a times log of 4. And I can divide both sides by negative log of 4 to solve for a. A negative divided by a negative is a positive, so I get that a is 2 over log of 4. Synthesizing all of the information I have, just putting everything that I know together, this then becomes that f of x is a is 2 over log 4 times what? Log of x plus 2 plus 1, or because this is a change of base, I could write this function as f of x equals -2 times log base 4 of x plus 2 plus 1. And that's it for 4.5. A lot of these are problems that you can graph in Desmos. So